Hello all, today in this video I'm going to make a demo for LSTM, that is long short-term memory, with the email dataset. This dataset we just downloaded from Kaggle. You can just give a spam email detection means you will just get this dataset. To just work with this LSTM, we are first initializing or importing the libraries which we are needed. Then we are loading the data set. So this is the data set which we are using, emails.csv. It is having nearly 3002 columns and we are getting the data of the column. You may notice that this is the only one entry which is the object type and all others are integers, that is only given over here. Then we are checking whether our data set is having any null values. You may notice that it is not having any null values, but if our data set is having any null values means we have to work with some pre-processing functions. Then within this x variable and y variable determination, from this data set, the initial first 3001 entries we will be using as the x variable, and the last entry, which is the prediction one, we will be using as the y variable. That is only given over here. Then by using this x variable and y variable, and the test size is 0.20, that is 20% for testing and remaining 80% for training. We are working and with the use of this train test split function, we are determining variables like xtrain, xtest, ytrain and ytest. You may also change this test size if you want some different testing and training ratios. Then by we are converting this vectors to vectors. For that we are just making use of the standard scalar function with the variables like xtrain and xtest. Then we are getting the shape of the xtrain variable. Why? Because the shape we will be using within the input shape, and mostly many deep learning algorithms will work only with the three-dimensional data. For that we have to reshape our xtrain variable, and then we are reshaping our two-dimensional data into three-dimensional by using this reshape function. Then this three-dimensional data, which is the second 3000 comma 1, will be using as the input shape within the LSTM layer, within the layer contribution. In the layer contribution, we are using the sequential layer followed by a LSTM layer with kernel size. Input shape as 3000 comma 1 and return sequences we have given as true. Then we are using a dropout layer with a drop rate as 0.5. Then another LSTM layer, in that previous same as the previous layer, but it is not having return sequences. Then again a dropout layer with the dropout rate as 0.3. Finally, a dense layer with output dimension as 1 and sigmoid activation as sigmoid. Why 1? Because this is a binary classification work. If it is a multi-class classification work means this 1 will be replaced by the number of classes which we are having. With binary classification work, we will be using only 1 as the output dimension, and mostly the activation we will give a sigmoid only for binary classification work. Then we are getting the summary of the model. Then we are compiling our model by using the loss as categorical cross entropy. Then optimizer, here we are using as Adam, and metrics as accuracy. Then we are training our model by using the fit function, and the variables like xtrain, ytrain, approaches we are training for 5 approaches. You may notice for 5 approaches we have got the values like loss, accuracy, validation loss and validation accuracy. Then we are displaying a classification report. Within the classification report we have got the values like precision, recall, F1 score and support. So the accuracy with Adam optimizer is 68%, and with confusion matrix also we are making a definition, and within this by using the definition we are plotting the confusion matrix. So this is the confusion matrix. Then we are displaying a graph by determining the validation loss, validation accuracy, then likewise accuracy, the loss, the training loss and training accuracy. So this is the graph we have attained, you may notice. So in the next video we will be working with uh, some other optimizer, that is SGD optimizer, and we'll make a comparison with this Adam optimizer and SGD optimizer. So here if you notice means in they are not merging above the other, and also this validation accuracy is less than the training accuracy only, but for a better system it should be higher than the training accuracy, but within this Adam it is lower only. So we can in the next video we shall see some steps to increase some subsequent videos we also see some steps to increase this validation accuracy. Thank you.